Hey kids, alright, today we got the start of section 8.2. Alright, it's not all that tough. It's very similar to what we've been doing, and it's got some prior knowledge in it with things like common denominators, but it's just at the level that we're doing it makes it a little bit difficult, okay, and it could be confusing. So if someone around you is having a tough time and you know what you're doing, be a good friend, be a good classmate, and help them out today, okay? So our first thing we're going to talk about is least common multiples with polynomials. Okay, least common multiples, you've done this kind of before with getting common denominators and adding fractions. And that's why we're going to be looking at it today, is we're going to be adding and subtracting fractions with polynomials and monomials. So we're going to look at getting the common denominator that we would need. Alright, so getting the common denominator is a pretty easy process. As far as the numbers, we need to do the prime factorization. Okay, so if you need to make a tree or whatever, you can do that. Alright, so 12 is going to be 3 times 4, but 4 is not done. 4 is not prime because 4 splits apart to 2 and 2. So we're going to have 2 squared times 3. And then we keep the letters kind of as they are, a squared times b. Okay? 15 isn't too bad. It's 3 times 5, a times b times c. No exponents on those. 8, right? 8 is 2 and 4, and 4 splits apart to 2 and 2 again. So we have 2 times 2 times 2. We have 2 to the third times b to the third times c to the fourth. Okay? So the numbers part is the only tricky part here. Okay, it's the only tricky part. Okay, we take the highest power of each factor. So I have 2's here. 2 squared, 2 to the third. I'm going to use the highest one, 2 to the third. Okay, my 3's, I have a 3 and a 3. They're both 3 to the first. It doesn't matter. We're going to take 3 to the first. This is the only 5. Got to take that one, 5 to the first. Okay. Now the letters, I have an a squared, that's the highest power of a. B to the third, we're going to use b to the third. C and c to the fourth, we use c to the fourth. Excuse me. Okay, now we're going to multiply these out. Okay, 2 to the third is going to be 8. We had that up there. Okay, 3 times 8 is 24. Okay, and then times 5 is going to be 120. Or you can just type that into your calculator. 2 to the third times 3 times 5. Okay, we're going to have 120. A squared, b to the third, c to the fourth. Alright, like I said, the only tricky part there is the numbers. Okay, prime factorizations. So if you need to make a pyramid or a tree, however you do those. Okay, and then you take the biggest power that you have out of all the groups, the biggest power for each number, and put those all down there, and then we have to multiply the numbers back together. And the letters, we just take the highest power of each letter that you have. Okay? When we have polynomials, okay, we're going to factor these out, okay, and then we're going to still do the same thing. We'll do the same thing. So this first one, I think I'm going to pull a 4 out right away. Those are all divisible by 4. Minus 3x minus 4. Much easier. What multiplies to negative 4 and adds to negative 3? Probably x minus 4 and x plus 1. Negative 4 times 1, negative 4. Negative 4 plus 1, negative 3. So there's those factors. 4, x minus 4, x plus 1. What about over here? Okay, these all have an x, so I'm going to pull an x out right away. Okay, this is going to be a little easier to do now. What multiplies to positive 20 and adds to negative 9? How about a x minus 5 and an x minus 4? Okay. Now I take the highest power of each one I have. So I have a 4. or 2 squared. So I have one of these out here in the front, so I'm going to use that. I have a regular x. Okay. I have an x minus 4 here and x minus 4 here. So I have an x minus 4 to the first, x minus 4 to the first. Doesn't matter which one we use. But you're only going to use one. You're only going to use one of them. Okay? X plus 1 to the first. That's the highest power I have of that. And x minus 5 to the first. And we can leave those there. Okay, so with these, alright, it's a little easier. Okay, you're going through, and if they match, really you're only going to write down one. That's the only difference then besides just pushing these all together. Is it, I had x minus 4 to the first, x minus 4 to the first. So by following my rule of using the highest power I have to the first, they tied, so it doesn't matter which one I use, but I'm only going to use one. And that's the only difference there between just shoving these both together, is that I only use the x minus 4 once. Alright. Why don't you give that one a shot? Let's see if I can get that both on the screen there. Okay, go ahead and hit pause, and you try one of these. Well, they're both part of the same problem. Okay, so we're going to take an x squared out of this one. Now we have x squared plus 8x plus 15. What's going to multiply to 15 and add to 8? How about a 5 and a 3? Alright, over on this side, what's going to multiply to negative 40 and add to negative 3? And to negative 40 and negative 3. How about x minus 8 and an x plus 5? Okay, so now we're using our biggest power of each factor. I have an x squared. Okay, x plus 5, oh, they match. Well, I'm going to use 1. X plus 3, that's the highest one I have of that. X minus 8, that's the highest one I have of that. And there you go. Okay, so we're just going to factor them up. Really what it amounts to is if they match, you only use 1, and then that's what's shortening it up as opposed to just squishing them all together. Alright, where are we going with this? Okay, we're eventually going to be adding or subtracting fractions with monomial denominators. Monomial, one big term. Okay, so step 1 is to figure out what the common denominator is. So I have 5, a to the third b squared. 5's already prime. Fantastic. 10. That's going to be 2 times 5 times a times b. So which ones am I going to take? Okay, 2, obviously, that's the only one I have. 5 to the first, 5 to the first, doesn't matter which one. A to the third is my biggest a, and b squared is my biggest b. So my common denominator is 10, a to the third, b squared. That's what I want the bottoms to be so I can add them together. What do I need to multiply this one by, top and bottom, to make it be 10 a to the third b squared on the bottom? Okay, the only thing this one was missing is that times 2. So I have to go times 2, top and bottom. Excuse me. So now I have 8 over 10 a to the third b squared. Plus, what does this one need? It already has the 10, but it needs to be a to the third b squared. So I need 2 more a's and 1 more b. So I need to go a squared b, a squared b. So now when I multiply this, its bottom's 10 a to the third b squared. And then on the top, 9 a squared b times c. And now I have a common denominator, so I can add these two fractions. 8 plus 9 a squared b c all over 10 a to the third b squared. Ta-da! Doesn't look like we're helping out too much, but that is quote-unquote simplified. Okay? So that is if you have a monomial on the bottom. polynomials on the bottom. Polynomials in the denominator. What if we have a polynomial? Okay, and I did not do the exact example out of the book for example 2, so you will have another one to look through that's all worked out and kind of compare that to. I did the simplify, the one in the book where you're supposed to kind of do the work on your own and try it out. So you will have another one in the book like this to look at. Polynomial denominators. Let's go with x minus 1 over x squared minus x minus 6. And we're going to do a subtraction one so you can see what that's going to look like. 4 over 5x plus 10. Okay. Now with these, I think it's a little easier because you don't have to do so much side work. You can kind of factor out the denominators on the bottom and it stays pretty easy. It's easier to see with these. Okay, and maybe you can apply the same technique we're about to look at here up to this one above it. But this is how I like doing the bottom ones here. So we're going to factor these out. Multiplies to negative 6 and adds to negative 1, x minus 3, x plus 2 on the bottom. Minus 4 over. This one's going to have a 5 on the outside, x plus 2. Okay, so in order to add these, they have to be the same. This one, what doesn't it have? Well, they have the x plus 2 in common. Okay, this one is missing that x minus 3. And this one is missing this times 5. So you take what they're missing and do that to the other side. So this one's missing the x minus 3 from over here. So I'm going to go x minus 3, x minus 3. This one was missing the times 5. So I'm going to go times 5 and times 5. Okay? So now on my bottoms should match 5 times x minus 3 times x plus 2. And then on the tops, we'll have 5 times x minus 1. Now this minus is going to tag along to the 4. Minus 4 times x minus 3. All over this new common denominator of 5 times x minus 3, x plus 2. Okay, for these problems, you have to simplify the tops. You have to simplify the tops. You don't have to simplify the bottoms, so be happy about that. Okay, but you do have to simplify the tops. So 5 times x, 5 times negative 1, negative 4 times x, negative 4 times negative 3. Okay, putting those two together, 5x and a minus 4x is going to be a 1x, negative 5 and a positive 12 is a plus 7. All over our denominator, 5, x minus 3, x plus 2. Okay, take a look at that again. Factored out the bottoms. Okay, they have the x plus 2 in common, but what is this one missing from that side? It was missing the x minus 3. So I did x minus 3 to the top and bottom. Okay, what was this one missing from that? It was missing that times 5, so I did times 5 top and bottom. Okay, so now they have the same denominators. Okay, so now I can add them together, or subtract them in this case. 5, x minus 1, minus 4 times x minus 3. Put them together as one fraction. Now I have to multiply those out to simplify. Okay, combine, and there we are. Let's give you one more of those, just to be sure, and then we're going to have to call it a day. I don't want to have a half-hour video. You guys are probably falling asleep. Well, let's pick one out from the homework here. Everybody likes that. Oh, did you just perk up? Paying a little more attention now? Let's do that. 18. Nope, boring. Let's do a fun one. How about 28? Okay, we'll have 8 over x squared minus 6x minus 16 plus 9 over x squared minus 3x minus 40. Okay? Factor out our bottoms here. What's going to multiply to negative 16 and add to negative 6? Okay, on this bottom we're going to have x minus 8 and x plus 2. Okay, over here, negative 40 and a 3. I feel like we've done this one already. X minus 8 and an x plus 5. Alright, now what? What do I do? They both have the x minus 8 in common. Okay, what is this one missing that that one has? The x plus 5. What is this one missing that that one has? The x plus 2. Okay, so now I have the same common denominator. It's a plus in the middle, so it's not very tricky. Let's distribute that. We got 8x plus 40, and this is a positive 9 times x, so that's a plus 9x, and x plus 2, so that's going to be a plus 18. That is a 2. That's a terrible 2. All over our common denominator. We don't need to write it out yet. Let's simplify this top. 17x. Put those two together, plus 58. Now we need to put our denominator into our final answer. X minus 8. X plus 2. X plus 5. Okay? And that whole bottom is all multiplication, so those factors can be in a different order. As long as they're all being multiplied, it doesn't matter. So it can be in a different order and still be equul. Yours doesn't necessarily always have to match mine. Alright, so that is our notes for day 1. We're right under 20 minutes still, so hopefully we're still awake. 8.2 day 1, we got page 541, 18 to 33. Okay, be a good classmate, be a good neighbor there. If you're getting it down, okay, help some others out. Alright? We will see you on Tuesday. Stay strong, kids. Do your homework.